In 12.3, we're going to look at a couple of special exponents. We're going to look at the exponent 0, and we're going to look at negative exponents. So if we want to first look at 0 exponents, we're going to look at patterns. That's what we base math on. So if we have 3 to the third power, 3 times 3 times 3 would be 27. 3 squared would be 3 times 3, or 9. 3 to the first power would be 3. So each time we're multiplying by 1 less 3, or we're dividing by 3. So we have 27 divided by 3 is 9. 9 divided by 3 is 3. And 3 divided by 3 is 1. And when we look at the exponents, 3, 2, 1, 0, we see that 3 to the 0 power is equal to 1. So a base raised to the 0 power is 1, as long as that base is not 0. So 3 to the 0 power would be 1. 5x cubed y squared, that whole thing, because we have parentheses, taken to the 0 power is 1. Negative 4, this is our base, taken to the 0 power, that's 1. But this one, we have 4 to the 0 power. This is 1, but now we're talking negative 1. So we've talked about this a number of times, that exponent only governs what it's next to. Here, it's next to negative 4, which is in parentheses. Here, it is only next to the 4. And 5x to the 0 power, this is 1. And now we have to multiply by 5, so our answer is 5. So you just have to remember, like the position of the exponent will affect what your answer is going to be. But anything to the 0 power is 1. Now let's take a look at negative exponents. Everything up to this point has been positive in 12.1 and 12.2. Now we're introducing 0, and now we're looking at negative exponents. So if we had this problem, x squared divided by x to the 5th power, we know that in division we would subtract the exponents. So 2 minus 5 would be negative 3. We can also look at that if we expand x squared, x times x, x to the 5th power, x times x times x times x times x, 5 factors of x. We can cancel out 2 x's in the numerator, 2 x's in the denominator, and we are left with 3 x's in the denominator. So these are the same thing. X to the 3rd power is the same as 1 over x to the 3rd power. And they tell us that another way to write some number or some variable to a negative power is to take the reciprocal and change the sign of the exponent. So it was negative, and now we're going to change it to positive. And we're going to take the reciprocal, which means we're just going to flip it over. So if we have x to the negative 3rd power, we're going to take the reciprocal, which is x over 1, then we're going to flip it to 1 over x, and we're taking that to the 3rd power. So 1 times 1 times 1 would be 1. That would be like 1 cubed, and then x cubed on the bottom. So 1 over x cubed. So here we go. Let's practice a little bit. So if we have 2 divided by 3 to the negative 2nd power, we can flip this and take it to, instead of the negative 2nd power, we can take it to the positive power. So we'd square the numerator, square the denominator, and there's our answer. On this one, we would have the reciprocal taken to, this is the negative third, so we're going to take it to the positive third power. So we would end up with 4 to the third power over 3 to the third power. And you could expand those if you wanted to. Okay, we've got 2 over x. We've got a variable involved, so we're going to take the reciprocal. We're going to flip this, and instead of taking it to the negative third power, then it's to the positive. So the reciprocal to the positive. So we would have x to the third power over 2 to the third power. So we learned this part on Monday, or the last time we met. Okay, so same things here. We're going to flip this. And instead of taking it to the negative second power, we're now going to take it to the positive power. Positive second power. So we're going to square the top, and now we have to square everything in the bottom. 3 squared, a squared squared. Remember, when we have an exponent taking it to a power, we're going to multiply the exponents. So here's our answer. Now, on this next row, we don't have fractions that we're going to flip, but we can make fractions. We know that 6 is the same as 6 over 1. So we can do the reciprocal. Instead of to the minus second power, we'll do positive second power. So we'll have 1 to the second power over 6 to the second power for our answer. Same thing with the next one. We can make a fraction out of the base. Now we'll take the reciprocal and make this negative exponent a positive exponent. So we have 1 to the 4th power over 2 to the 4th power. Same thing on the next one. We just have a variable here. We're going to take that to the negative 5th power. So we have 1 to the 5th power over x to the 5th power. Same thing here. So we're going to have this. We're taking it to the positive third. So this is 1 to the 3rd power over 3 to the 3rd power. And it's going to be negative. It's going to be negative. Okay, let's look at the next one. We can make each of these positive. Make them each of these fractions. And now, instead of the negative 3rd power, we're going to flip this. This is already positive, so we're good just to leave it like this. And we're going to take it now to the this is still the negative 6, so we need to flip this over. We have y over z to the positive 6. So we would have y to the 6th over 2 to the 6th. Now, what I like to do with these negative, when they're written as a fraction, you can always do what I'm going to call jump the line, and we'll look at that a little bit later down here. And what that means is on this one in here, if it's negative up here, we'll just jump it to the bottom. In other words, that's part of the reciprocal. Okay, let's look at this next one. Again, this is x to the negative 7th divided by x to the 4th. So what we know is we're going to, instead of dividing, we're going to multiply by the reciprocal of this. So we have x to the negative 7th times 1 over x to the 4th. Now to make this positive, we're going to use the reciprocal of this. And that's going to be to the 7th times 1 over x to the 4th. I'm kind of running out of room here. I'm going to have to go down below. So this right here would be 1 to the 7th over x to the 7th times 1 over x to the 4th. So the top is going to be 1, and the bottom's going to be x. We're multiplying these, so we're going to add the exponent to the 11th. Now this is one of those problems that I was talking about that we can jump the line. Let's take a look at that. So we have a negative exponent up here. So we're just going to jump the line, and it's coming down to the bottom. So the bottom's going to be x to the 4th times x to the 7th. So instead of the negative up here, we have a positive down here. We have to have something on the top, so that's a 1. And we end up with the same thing that we had up here. Okay, let's look at this one. Now, what we know is this negative exponent only controls the x, so we're going to leave the 2 on the top, and this is going to jump the line. Same thing here. We're going to flip this, and it's going to be the positive 4th power. Same thing here. We're going to flip this, and we're taking it to the 2nd power, so the top is going to be 1 to the 2nd power, the bottom is going to be 5 to the 2nd power, y to the 3 times 2 would be 6th. Or simply 1 over 5 squared, or 25, y to the 6th. Okay, we've got 2 more. I see a negative exponent, so what I'm going to do with that is I'm going to jump it down to the bottom. I have 11. I think there's supposed to be maybe an A in here, and it's not in there. And I'm going to jump this up to the top. This is what's going up to the top. Sorry about that. Okay, so let's write that out. We've got 22 a to the 7th, and we're jumping a to the negative 2nd up here. And then on the bottom, this is negative, so we have 11, and we have b squared, and now we're jumping this one down. Now let's simplify this. We know this is easy. That's going to be 2. And we have, this is multiplication, so we're going to add the exponents. And on the bottom, we have b, and we're going to add the exponents. So there's our final answer. We have one more to do. And I'm going to slip down here and write this. So we have a negative exponent up here on the top. So this is going to be, this whole thing right here is going to jump to the bottom. Everything's positive down here. So we'll have to have something on the top. So we'll put our 1 up there. We had x squared y cubed, and that expression is squared. And now we're bringing this down. We have 2x, and our exponent becomes positive. So let's simplify all this. We have to take both of these to the 2nd power, so we're going to multiply the exponent. So we have x to the 4th, y to the 6th. And now we have to take both of these to the 3rd power. So now let's simplify this. We've got some x's. I'm going to start with the constant, so I have 1 over 2 to the 3rd power. Now how many x's? We have 4 and 3 would be 7. And then we have y to the 6th. So I realize that some of this is pretty messy, but if you just kind of listen to what we're doing and maybe work these one at a time, you'll be fine. So we've talked about an exponent of 0 means that's worth 1. And now we're talking about negative exponents. Negative exponent is equal to the reciprocal, flip that, to the positive exponent. And I like to use this little idea of jumping the line. So if you have a negative exponent on the top, it jumps to the bottom. If you have a negative exponent on the bottom, it jumps to the top. And remember, like I forgot for a moment, that negative 2 exponent only controls the a, not the 11. So the 11 can stay down here, and the a squared jumps, a to the negative 2nd, jumps to the top. The 22, a to the 7th stays up there. And then we have the one that we jumped up there, a to the 2nd power.